So today this is 10.1. This whole unit, we're starting a trig unit. And so this unit is triangles and trig. We're going to review something that you guys did in Math 2, okay? And it was the way you can solve a triangle. Again, if you know really a side and an angle, you could solve the triangle as long as it's a right triangle, okay? And that was using SOHCAHTOA. Do you remember that? These were ratios of sides in relation to a trig function of an angle, okay? The first letter was the trig function, okay? Do you remember what the S stood for? Yeah, the S stood for sine, and really it's S-I-N-E, and then they abbreviated just for whatever reason, and so you'll see on all your calculators, they just cut it off so that it's the first three letters, okay? So S-I, but you say that sine, not sin, right? And it was that the sine of the angle equaled, what did the O stand for?
Cosine.
No, what did the O here? Do you remember? Opposite and hypotenuse. And really, the only kind of triangle that could have a hypotenuse is a right triangle. So all of these ratios are used when you have a right triangle, okay? And then we're going to actually learn later how to apply them even if the triangle is not a right triangle, okay? What did the C stand for? Cosine. And you actually spell that C-O-S-I-N-E. But again, we just cut off the I-N-E, that COS, you say cosine, not cos, but cosine. And you would write the cosine of the angle is equal to, what's the A? Adjacent. And then the H again is hypotenuse. And then finally, the T here stood for? Tangent. Which again, they'll abbreviate tan, but it really stands for tangent. Okay, that's the entire word. And again, that's opposite over adjacent. In a right triangle, that's how these ratios are defined. Okay, so I'd like for you to set up a right triangle here. Let's put the right angle at C, and then let's put A and B as the two acute angles. What's an acute angle?
Smaller than 90.
Smaller than 90, yeah. So A and B have to be less than 90. How do I know that? Why do they have to be less than 90?
1 equals 180.
Okay, because they all have to add up to 180. If it was bigger than 90, it'd be bigger than 180, right? So they have to be less than 90. Okay, let's say that AC is 4 and that BC is 3. And what I want you to give me is, what is the sine? This is how you say it's sine, right? Sine of the angle. I want you to tell me what that is. I want you to tell me what the cosine is. And I want you to tell me what the tangent is. Okay, for A, using these. Oh, what did I say this was? This was supposed to be 3, and I wrote C. Okay, that's supposed to be 3. So obviously using these ratios with sine, I'd need the opposite, and I would need the hypotenuse. We don't have the hypotenuse, but hopefully you could just look at that and tell me what the hypotenuse is. 5, yeah. Okay, because it's a Pythagorean triple, 3, 4, 5. If you didn't see it, how could you find it? Pythagorean theorem, right? 4 squared plus 3 squared equals whatever you want to call that, C squared. Okay, now let's look at angle A. Look at angle A here. Which side is opposite angle A?
3.
The 3, right? It's the side that's furthest away from it. It doesn't touch it at all. This side here does not touch angle A. It's opposite it. And then obviously, which is the hypotenuse? 5. So the sine of A would be 3 over 5, and we're just going to leave it like that. We're just going to write it as a ratio. That's it. Okay, the cosine, adjacent over hypotenuse. Which one's the adjacent? 4. It's the side that's right next to it. It hits it, right? It's part of that angle. That's not the hypotenuse, right?
Well,
we obviously know.
5, that hits it.
Right, so that's why it's the side that hits it. That's not the hypotenuse.
Oh.
Okay, so every acute angle will have the hypotenuse as one of its sides. The other one is the adjacent. Okay, so this would be 4 over 5. And then tangent is opposite over adjacent, 3 over 4. Is there anybody that's never worked with this before? Has everybody done this before? Have you done this before? Okay, good. All right, let's do now for angle B. The sine of angle B. Let's start with that one. Javier, what would be the side that's opposite B? 4, okay? And since sine is opposite over hypotenuse, we'd say it's 4 over 5. Cosine of B. Alyssa, can you tell me, Alyssa C, can you tell me what the cosine is?
30.
Over 5. And then the tan of B. Jason, can you tell me what the tan of B is?
4 over 3.
You guys agree? Are we good? Question? Okay, again, we would do these right now using SOHCAHTOA. You do those for the acute angles. We don't do it for the right angle. There's a whole different method that we'll use when we get to right angles that we're going to learn later in this unit. Okay, so the next type of problems that you're going to have, let's call that example number 1. The example number 2, I'm going to ask you to solve for x first. I want you to solve it as though you didn't have a calculator completely, and you might leave it as something like x equals 10 tangent 45, you know, something like that. But then we're going to punch it in our calculator, and we're going to take it out 3 decimal places. Okay, so first solve for x. After that, then plug into calculator. Round to the thousandths. Which is 3 decimal places. Okay, first one, go ahead and draw a right triangle here. And here's what we know. The hypotenuse is 24. This side is x, and this in here is 71 degrees. Okay, so as you remember from your Math 2 days, what you're supposed to look at is that angle that you know, 71, I'm going to circle that. Then I'm going to look at, obviously 24 is the hypotenuse, okay? That's not really what I have to concern myself with. What is this in relation to the 71? Is it the adjacent or is it the opposite? You're already telling me how to do it. It's the opposite, right? So which one does opposite and hypotenuse? Sine, yeah. Okay, so again, the way you set it up, it's the sine of the angle. The sine of 71 degrees would equal opposite over hypotenuse. Okay, then it's a question of solving this. I want to solve this for x. How do I get rid of that 24? Multiply, right? Multiply both sides by 24, or in essence, you end up multiplying it over. It comes over 24 sine 71 degrees equals x. Or multiplying both sides by 24 to cancel it, right? Reduces here. Now the 24 would come over here. Okay, so that's the first part. Solve it for x. And then now we're going to punch this in our calculator. I saw a couple of you have a graphing calculator. Anybody have theirs here today? If you're using a graphing, you need to make sure you're in degrees. A lot of graphing calculators are in radians. We're going to learn what a radian is later too. But okay, so pull out your scientific calculator, and you can just type in 24 times the sine of 71. Mine just lets me type it in like this. Can you type it that way, or do you have to put a multiplication sign? Okay. And then, oh, I don't know, maybe, let me check my mode. I think I'm in radians. I am. I need to switch to degrees real fast, and I'm going to do it again. Are you guys getting 22.692? Interesting, those answers were actually pretty close. Okay,
Wait, what's
so
the difference that you do?
you're okay.
She was in a different mode.
I was in a different mode. I was in something called radians that we're going to learn next week, what a radian is. It's another way to measure an angle as opposed to degrees. Okay, so here we go. 22.69. Take it out 3 decimal places. What would it be? 692 or 3?
3. 2.
2, right? Do we have any units? No, so it would just be units. If we had like centimeters or something, we would include that. Okay, so that's after you punch it in the calculator. All right, let's do another one of these. All right, let's draw a right triangle this way. In this case, this angle here is 28 degrees. This side is x. This side is 15. Okay, so we want to use just that information, use one of our trig functions and figure out. So here is the angle. We relate everything to the angle, right? What is the x in relation to the 28? This is the adjacent. What's the 15? Opposite, right? So
Tan.
this is the adjacent, this is the opposite. So we're going to use which trig function, Ava?
Tan.
Tan. So we'd set it up, the tan of the angle, right? The tan of 28 equals, how would it go?
X. Wait. 15 over X.
15 over x? What do you guys think? 15 over x or x over 15? Which way should it go? 15 over x, right? The opposite over the adjacent. Okay, now, how do we solve something like that when the x is down in the denominator? I'd multiply, yeah, I'd move it up. Let's multiply both sides by x to move it up. And just leave this as x tan 28 for now equals 15. Those x's canceled. That was the idea. And then divide by tan 28. Now I want you to notice what happened, you guys. So this would be writing it, solve for x. Okay, so that's the first part that we're doing. I want you to notice what happened.
You divide it.
When the x was in the denominator, and then we moved it over here, and the tan, look what these did. They just traded spots. You know what? It's always going to work out that way. If the x is down in the denominator and you have something equal here, you can just trade, they can just trade spots. As long as it's the x that's down in the denominator, okay, because you cross multiply and then you divide. Those just trade. Okay, now you're going to punch that in your calculator.
28.210.
28.211. Okay, and again, if we'd had some kind of units, inches or something like that, we'd put that. Okay, try this one. Draw a right triangle. This angle here is 65 degrees. This is x, and this is 8 root 5. That's a 65 degrees. Okay, so again, in relation to this angle here, you want to look at what these are. Okay, what's the x? That's the hypotenuse, right? That's the h, that's the hypotenuse. What is 8 root 5? Adjacent, so that's the a. So which one had a and h? Cosine, right? Adjacent, hypotenuse, cosine. So we say the cosine of the angle equals the adjacent over the hypotenuse. Right? Okay, now what's going to happen, you guys?
X and the cosine divides their spots.
These guys are going to end up trading spots, right? Because we'd multiply the x over. I'll show it one more time, show you that it really happens. We'd multiply the x over, and then we'd divide by the cosine 65. But those two just end up trading spots. Again, a little time saver when we're on the test. Help us save a little time there. Okay, and divide that, what do you get?
42.328.
Okay. You guys agree with the rounding? 42.328. Okay. So again, that would be that side. All right, so that's all the different trig functions to solve for a side. Do you guys remember doing that? Pretty easy. Okay, now what if it's the angle we're solving for? Does anybody remember how that changed anything? What if it's the angle that we don't know? So like this, draw a triangle like this. And let's say this angle here, we don't know, it's x degrees. Let's say this side's 31 and this side's 25. I would still start the same way. I'd set it up the exact same way as what we were doing. I'd look at this angle and I'd look at what the 25 and the 31 are. Obviously, what's the 31? That's the hypotenuse, that's the h. What's the 25? That's the adjacent. So that's still which trig function? Cosine. So again, you say the cosine of the angle, okay, is equal to, how would it go? 25 over 31. Okay, now there was something we did at this point. Does anybody remember how we solved for this? I want x. There was a special button on your calculator that you used when you were solving for the angle. Do you remember, Zion, what it was? Yeah.
Opposite cosine.
You did second cosine, yeah. And you know how you read that, you guys, that cosine, and it looks like it's cosine to the -1. You read that inverse cosine.
Yeah.
Remember when we did inverse
Yeah.
functions? And it had that, it looked like a power of a -1? That's what it is. Now, when you do that, you don't write cosine over here anymore. You write it like this: x equals inverse cosine 25 over 31. The inverse undoes, remember it undoes the original function. So when what I did was I took the inverse cosine of both sides. The inverse cosine and cosine canceled out, leaving just x. Okay, but this is what I would write. That could be the correct answer as well. And then you just punch that in your calculator, right? So inverse cosine 25 divided by 31. 36.24. You guys agree on the rounding? 9. And then now this is an angle though, so what should I put? I do know units here, degrees, yeah. 36 degrees is what would give me that. Okay, scale 1 to 4. 1, I totally have this. I don't need to see another example. 4, I really need to see another example. Can you tell me where you're at, 1 to 4? Lucy, what do you think? So, yeah.
How do you get the opposite cosine? No, I get that, but like, what makes you like do opposite cosine?
Oh, okay. I want to get rid of the word cosine. The way you undo cosine is you take the inverse of it. Inverse of cosine is this. Really, this is what we did, okay? It's a little bit ugly at first, but really what we're doing here. What's
You're
that?
just asking when do we
When,
use
oh,
the
when to
inverse
use it?
cosine?
Oh, not what do we do it for?
When the
It's when you're
x
solving.
is-
Go ahead,
You just
say it.
want- Okay, so yeah, okay, I get it.
When you're
So,
solving for the
yeah,
degree.
We're trying to find a degree.
Yeah. We're trying to undo this. You're trying to get this all by itself. Again, theoretically, this is what we're doing. We're doing the inverse cosine of both sides. And these guys cancel out because they're inverses. It's like when you have 2x, 2 times x, and you divide by 2. Division's the inverse of multiplication. They cancel out. These cancel. But it's when you're trying to solve for the angle that you use inverse cosine. Yes. Okay. I had just had a couple people, so let's just do one more where we solve for the angle. Okay. So let's say that this angle is x degrees right here, and let's do 5 and 7. Okay, so same reasoning as far as setting this up. You're going to look at this angle. Kenna, can you tell me what's the 5 in relation to the x?
The opposite.
Opposite. And what's the 7?
Adjacent.
Adjacent. And Grant asks, what uses opposite and adjacent? Cosine is no. Tangent, yeah, TOA, right? Tangent. So we'd say the tangent of the angle equals the opposite over the adjacent. So here's the case where now, to get rid of that tan, I'm going to do the inverse, right? So that's the case where you use it. So x is equal to inverse tan 5 over 7. Okay, punch that in your calculator. What do you get? 35.538. You guys verify the rounding on that?
Yeah.
You agree? Okay.
Yeah.
Degrees, and so that would be that angle. All right. We're going to take just a few minutes to review one more thing, and that's those special right triangles again.
So is this all a review?
Today is all review,
Oh, perfect.
pretty much. Yeah. So that's nice, huh? Okay. What Roman numeral was I on?
E.
Oh,
2.
2?
Roman numeral?
Yeah, let's go to Roman numeral 2. Okay, so Roman numeral 2, these special right triangles, I want you to have these in your notes. And you guys, we're going to be doing a lot with these special right triangles, so you really need to know the sides here, okay? So again, reviewing this, if you have a 30, 60, 90, we good? Okay. 30, 60, 90, what were the side lengths when we did that? If one of them was A, how did it go?
A root is
We had A,
2A and A root 3.
2A and A root 3. Okay. Which is bigger, 2a or a root 3? 2a. So actually, I'd get in the habit of doing it a root 3, 2a, just to keep it in order, okay? So your shortest side is a. What's always going to be your shortest side in a 30, 60, 90? The side opposite the 30, right? This is going to be the shortest side. Then the next biggest side is opposite the 60. And then the biggest side should be the hypotenuse. And 2 times a is bigger. Root 3 is about, what? 1.7? Okay. So this is 1.7 times a. This is 2 times a. Okay. All right. Draw a 45, 45, 90 triangle. Okay? And what were the sides on this one? 45, 45, 90. How'd they go? A root 2. Good. So I heard somebody say once, you got 3 different angles, so you got 3 different measurements here. Here you only have 2 different angles. You got a 45 and a 90, so you only have 2 different, you know, A root 2, whatever works for you. Okay, so solve this, you guys. Solve the triangle. If it asks you to solve the triangle, that means find absolutely everything that's not labeled. Angles and sides. Okay? So find all the rest of it. Number 1, 45, 45, 90. And I'm going to give you that this side is 6 root 2. And actually, I had intended to leave this angle blank. So in the example, you're going to have that angle blank. So you're going to have to fill that's 45, and then find the other 2. Okay? So this one goes, what's the one for 45, 45, 90? A root 2. We've got the a root 2. Right? 6 root 2 is a root 2. So what's a? 6. And you would just fill that in. Okay. One more of these and I think we're good. Make this one a 30, 60, 90. And this side is going to be 20. Okay, so actually this is the way it's going to be on the worksheet. You got 30 in that lower corner, so hopefully you know right off without even really thinking about it much that this angle, which I already said, is 60. Okay. And then you got to figure out what that 20 is in the spot of. How do the sides go for a 30, 60, 90? A root 3, 2a. What's the 20 in the spot of? 2a. This is in the spot of 2a. You want to find a first. So what would a be?
10.
Where's that going to go? Opposite the 30. And then what's this side going to be?